What is up, everybody? I was recently inspired by a kind of CSS only implementation of the infamous Star Wars scrolling text and thought, how could I create something that was the opposite of CSS only and used a lot of JavaScript and kind of modern techniques to create something kind of interactive and dynamic. So the user controls the scroll, the user can move the stars, and as they scroll down, the text fades out. Eventually, everything fades out to black. So in this video, we'll be diving into points, particles in React 3 Fiber. So they kind of do a bit of a 10-minute crash course on those, show how you can use simple geometry such as a sphere or a box, and then we go into placing those points on the surface of a 3D model. And after that minor detour, we return to the stars and creating those using a custom vertex and fragment shader so that we can get this really kind of unique user-based interactions. And then finally covering the animation of the text in the 2D part of the page. Hope you enjoy it, and let's dive in. Alrighty, so got a few topics to cover in this video, and hopefully should give you a pretty good introduction to working with points or particles in your React 3 Fiber project. So we're going to look at the basic point setup with predefined geometry such as a sphere or a box, and the generic out-the-box points material. Then we'll look at how you can create a custom geometry to position those points more randomly, and how we can then create a custom shader material to style the particle how we want. After that, we'll take a brief detour into sampling a 3D model and positioning our points on the surface of it. And then we'll get onto the stars, and we'll use a custom vertex shader to move their positions as you scroll down, and the fragment shader to give them the sort of soft circular aesthetic. And then after we've done the 3D work, we can get started with the HTML. So we've got our text, which is transformed using perspective and GSAP scroll trigger to animate it as we move down the page. Okay, so I've got the canvas importing from React 3 Fiber and the orbit controls from React 3 Dre so that we can drag it around and take a better look at it. Inside the canvas, I've created a basic particles component, and right now we don't need to be concerned with these or this. What we have is our points element, and then inside of that we need to provide it with some geometry, or we need to attach geometry to it, so we can use a box or a sphere, and we need a material. So in this case it's just the points material with some attributes such as size and opacity. Now what we have in the browser is this. We can adjust the arguments on the box. So at the moment it's 111 on its width, height and depth. And then the number of segments actually determines the number of points. So now we have a lot more. We can add size attenuation, which means that points that are further away from the camera become smaller, and that kind of gives it a nice depth effect. We can add additive blending, which doesn't seem to be working quite right here. Not sure why that is the case. Okay, yeah, we can see it better here. It basically means when points overlap, their colors will be added together, so you get a brighter effect when that happens. So if we switch this over to the sphere geometry, it's more evident at the top here and at the bottom. As they're overlapping, we're kind of getting a more intense color, which is really nice. So to recap here, the most basic setup is the points with a geometry and a material. And you can obviously choose the color as you wish. So what if we don't want them to be positioned over our sphere or our box? One thing we can do is define how many particles we want, and then we can use a function to generate their positions programmatically. So in this case, this is a function that receives the number of particles. It then creates a float32 array, which is the format for the positions to be stored in. We need to multiply the count by 3 because we need to insert an X, Y, and Z position for each of those particles or points. So every point, in this case 512, will need three slots in the array. So here we are basically, there's just some math to position them randomly around a sphere. And our end result with this one is that we need to attach it. So rather than using the predefined geometry, we are attaching the geometry with the attribute for its positions here. And you see that the count is actually the length of the array divided by 3, but it could also be just the particle count here. In fact, we're saying that the array, there's 3 items for each element. Now what we should expect to see are, yeah, particles positioned randomly. They are tiny though. That's a bit better. Okay, cool. So now we've got them positioned in our sphere more randomly. It's possible to attach other attributes beyond just the position of them. I haven't dived into that topic much, so I'll leave that out for now. It's also, of course, possible to add different materials other than the generic points material. So what we can do here is use our basic particle shader material. So what I've done at the bottom of the file is uniforms of just time. I don't think we're actually going to be using that. We've got a shader material from React 3 Dre, and a particle vertex and a particle fragment shader. We've then extended it and set up TypeScript so that we don't see any errors. And we've got a ref on it here. So now this shader material will be attached as the material like that. We don't need to explicitly state that, but that's what it will be doing. Then we require both a vertex shader and a fragment shader. So this is the standard vertex shader for the positioning, but we also need the point size. And so the point size can be a standard float, such as 40. And now these are all exactly the same size. If we want to code our own size attenuation, which we probably do, we can add this formula here, which will use the Z position to and multiply the result by the maximum point size. So in this case, the nearest will be 64, and they'll get smaller as they get further away. So you can see here, we're kind of getting closer to that end result. And there's a nice sort of randomness to how these are positioned. Of course, if we go back to here, we could increase this 1024, let's say. Now I've got a lot more. These are surprisingly performant as well. This looks dope. The fragment shader, I'm not going to go into all of the sort of the setup of this, but I do have another video that kind of goes through a lot of these functions for a beginner. But basically, we need to assign the GL frag color to the color of the particle, and in this case, we are creating a circle. So GL point chord, which is the corner of the pixel or texel within this individual point. We're then calculating how far that is from the center, and then using a step function, we can say if it's greater than 0.5, it's 1, or if it's less than 0.5, it's 0. So then we can end up with a perfect circle. And obviously, if we change this, we adjust the size of them. But going above that won't work. Yeah, and then we're just multiplying the opacity by the value of the circle. The circle opacity is either 0 or 1. So yeah, and anyway, we end up with a circle like this. We'll get on to creating a smooth circle for the actual stars in a moment. All right, so now you've seen how to set up some basic points. If we wanted to pass time into the shader, we've got access to it via its ref, and then we can use it here. So for example, let's say we wanted to update the color. We can get the time, put it into a sine function so that it oscillates between -1 and +1, and then we normalize it between 0 and 1. So what we'll see here is a value that goes between 0 and 1 for each of these. So it should move between white and black and all the colors in between. Oh, actually, no, it'll just be grayscale, won't it? Maybe we just do it on one of the color channels. So then we get something like this. And obviously we can either color the points based off of their position, which we can get from the vertex shader. If we choose to pass that in, these aren't actually being used, but we could define some varyings and then grab the position. Let's say we did that. We used its V position here. Now we can see that as its position is changed, it's affecting the color. Okay, so back in the main page, I'm going to now comment out the basic particles component and add in the mesh sampler particles. And here what we can do is load our 3D model. I've downloaded mine from Sketchfab, so credit to Lil CJ for this Black Panther model. I've chosen this one because it works nicely for the effect here, and the code's quite simple. It's not set up to work with complex models. So basically, we are don't know why I've done ×2 here, but we are generating the positions like we did earlier, but we're doing it once the GLTF has loaded. Then we're traversing it, looking for the mesh. Then we can use the surface sampler, which can sample random points on the surface of a mesh. And so then with that, we can create 4,000 positions that are all on the surface of the mesh. And so here, again, with the array, with the float 32 array, we need to multiply the count by 3 and then add an X, Y, and Z position, which has come from the sampler. And down here again, we're then attaching those positions as the attributes on geometry with our standard points material. So now what we have is our Black Panther with points all over its surface in random positions, and the size attenuation is enabled, and the additive blending really kind of starts to show here, especially when you look at it from different angles. What would be cool if you could try and disperse these and bring them in. You could have an effect that, say, they move, they animate in, or they move in relation to the pointer. I'm actually going to create another video in the future where dive into more on particles, points on the surface of models, and I kind of really want to get this scene where you transition between different models smoothly as the user scrolls down, and that's a little side project that I've been exploring, and can't wait to share. That was a minor digression because we don't actually need a model for our star scene. Okay, so let's get into the stars component then. We have our particle count and a function to generate the random positions. Again, we're assigning an X, Y, and Z position for each of them. The Z depth is used here to kind of get a deeper, get more depth than there is width and height, basically. And the spread is, just played around with figures to kind of get a wide enough plane initially, and one that gets smaller as you scroll through it. So you'll see what I mean in a minute. It's almost like a pyramid where the density increases the further away they are. So what we have is this set of particles that are more densely packed towards the middle. But as we scroll through it, this happens. Which is pretty cool. Again, this function I just played around with a little bit to get some values that worked. The shader material has the time and scroll progress. I don't think we're using the time, but if we wanted to say add a constant movement to the particles, then we would use that uniform. So we're setting the scroll progress every frame, and well, we're setting the uniform every frame, and we're setting the scroll progress when the GSAP scroll trigger updates. So this is saying start of the page to the bottom of the page. Get the progress and assign it to our ref here, and then pass that into the uniform. So we'll have a scroll progress value that ranges between 0 and 1 as the user scrolls the page. Now, in order to actually get the scroll trigger to work, I'm going to need to remove the orbit controls from here, add in the pointer camera. This was a little camera component that we made in a different video. Essentially, it just tracks the pointer position and then adjusts the camera slightly, so it gives it that kind of movement as the mouse is moved around the view, but it won't hijack the scroll, which orbit controls does. So now we can look at the vertex shader. So we've got our movement happening now based with that pointer camera component. So the vertex shader, where it gets a little bit more complicated, really we are using the scroll progress value, which, as I say, ranges from 0 to 1. And then we can mutate the Z position of the particle, which is its position, based on that. And I've applied a multiplier just to increase its effect slightly. So yeah, we're going in and out, and we aren't actually, we're doing that to the points in the vertex shader. Standard kind of position computation stuff here. The attenuation factor is again done, but in this case I've clamped it with a minimum and a maximum point size just to prevent it getting too small. And then we assign the point size and the position here. The V-view position is a varying that I've added and are passing into the fragment shader so that we can fade out the points that are really far away. So what we have now is the scrolling in and out. In order to add the rotation, I'm going to use this GLSL rotate package and the 3DZ rotation. Then what we can do is multiply the particle position by the 3D rotation function response, which is the function return value, which is taking the Z position and the scroll progress. And basically what this is doing, if we put in time here instead of scroll progress, we'll see it happening without any scroll. So the particles around the outside are moving a lot quicker. So it's sort of like spiral effect. Get dizzy looking at this for too long. But I don't want it to be that intense. We could use a combination of the time and the scroll progress if we wanted to. Like we could, let's put in the scroll progress to begin with. So yeah, now we're getting this rotation effect. Which is pretty cool. I don't actually think the negative value has an effect there. Oh, it's just the way in which it spins. Either it goes clockwise or Now it's going anti-clockwise like this as you scroll down. Yeah, if we wanted to use the time to actually add a constant movement, maybe what we could do is get time rotation is u times like that or something, and then just add it here. If I increase that intensity, I think we need to minus time as we're going in that direction. So now it's always moving, but the scroll is having a greater effect, especially if I knock this down again. So kind of subtle rotation. I quite like that. Yeah, and we have the view position going into our fragment shader. So look at the fragment shader next. Much like the basic particle fragment shader that we checked out earlier, we also want to create a circle, but in this case we want a soft circle rather than a sharp one, just so we get a more sort of star-like look to it. So we're going to do the same calculation from the center of the point, but we're going to smooth step it rather than step it. So this will then create a soft edge on the outside of it. Can play with this value to get a sort of sharper or a smaller blur radius on it. Yeah, this is looking cool. In order to fade them out, there are different ways to do this. I'm not saying this is necessarily the best one, but what I've calculated is the distance that they should be sort of fading from, and then using that varying that we have from the vertex shader, so the position in the view relative to the camera, we can then smooth it out between if it's 6.5 away and if it's 3.75 away. When it's within that range, it will go from 0 to 1 opacity. And so what we can do now is if we create a float for opacity and we do circle times the distance fade, rather than just put that in there. So now we see those brighter stars, as they get further away, they're fading to 0. And kind of want that, because this is such a bright thing at the start, it's hard to put text over that and have it still legible. So that kind of distance works quite nicely. We could, if we increase this, you see now it takes much longer for that to fade out. In fact, it doesn't really move enough for it to fully fade out. That's nice. The other touch is having it completely fade to black at the end. I mean, we might not need to do that, but if we do want to do that, we can use the scroll progress, which is from 0 to 1. When the progress is 1, the user will be at the bottom of the page. And so if it's between 1 and 185% scroll, it can then change the value from 0 opacity to 1 opacity, so it will fade. This is backwards, it's a little bit hard to visualize, but when it's at 100% scroll, it'll be 0 opacity. And then at 85%, it'll be full opacity. And then we can multiply that by our other opacity values. So nothing will change. We'll get to 85% around here. Then everything will fade out. I did have a 0.9 multiplier on that because I wanted them all to appear slightly transparent to ensure that this sort of additive blending was working. So yeah, I've just dropped whatever the full opacity is by 90 down to 90% here. Could play around with that. If I do that, then you see the overlapping is only really intense in the middle. We could have a play around with this value. It's quite nice. Okay, so let's get started with reviewing the 2D, 3D text content. I've got the outer container, which is fixed with our perspective and our transform style. I've got an inner container, which is the div within it that is going to rotate. So we've got our section, and we've got a div inside of it, and that's the one that we're going to rotate like this, so that the text will then move through that. We could move the text itself, but what I wanted to do was fade out the top of the text. So by putting a mask on the inner container, we can angle the inner container, add a fade at the top of it, and then move the text up so that the text disappears always at the same point. And it also means that we don't need to transform this, which will be which will kind of move it all further away. It'll keep it hard. It would be hard to keep the text at the same position. So yeah, we've got an inner div that we're going to rotate, and then the text itself, which is what we're going to translate through that container. The use GSAP hook has been set up, and what I'm demonstrating here is that you can have mobile and desktop animations, and in this case I'm not adjusting the animation for desktop or mobile, but instead setting the degree of rotation. So when it's a small screen, we're only rotating the container by 16. When it's desktop, it's 48, and we're also adding a translate to pull it up a bit. So set the initial styles on that. Now if we take a look at it, we can see this is our container. If I put a border, say, can I do that? Nope. Yeah, and this is basically the plane in which our text is going to move along. We can't see the text at the moment because it's set to opacity 0 to begin with. That's just to prevent it flashing in. But yeah, here we go. So start the text hidden. You may have heard me say before, it's quite a common practice to use a CSS value to set the opacity to 0 if you're then using JavaScript to animate it. Just means that if it flashes on the screen and before the JavaScript loaded and run and moved it, you don't have that flicker of content. So we hide it to begin with. And then at this point, we kind of are confident that the JavaScript's ready and that we can then position it properly. So it's showing again. And then finally, to move it, we have a timeline which has a default of no easing. And in fact, this doesn't even need to be a timeline because there's only one tween happening within it. We just want to specify no easing. So then we target the paragraph. We start it at 50% down, and then we're going to move it to minus 100 so that it will completely leave its container. And we'll do that using a scroll trigger with a scrub value so that it controls the progress from 50 to negative 100 Y%. Now, we could probably move that. We don't necessarily need to start at minus 50. It could start a bit less than that, but there we have it. It's fading out here because we've got our mask at the top. Which we can change if we want it to fade out more. We could increase that, but then you don't really get to see much of the text. I think 20-25% works quite nicely. Take the border off of this. Yeah, so there we have it. We've got our stars, particles, they're rotating slowly. And because that rotation is using their Z, they're not all rotating at the same pace. You'll see if you can pick out a big particle up here, that one's moving at a different speed to one further away. And then we also rotate them and translate them on Z axis as the scroll progress value changes. So it gives this effect of us kind of moving further away from the galaxy, and we're then using the view position as that happens to fade them out. And the text here kind of looks like it's fading out into the background as well. There we have it. Smashed it. I hope you enjoyed this one. As always, give me a thumbs up. It really means a lot. And yeah, hopefully see you soon in the next video.